time to present myself. I'm Isabelle van Campenhoudt. I'm from Brussels, and I'm a data platform MVP for 10 years now. It's quite a long time ago already. I've been working on the Microsoft data platform since the last century, even the last millennium, I may say.
Oh.
And I'm a total data addict. So you can follow me on Twitter, on my blog if you want. You can reach me by email as well. Just never give me a phone call. I do not answer my phone. That's all. So time for Arnaud to present.
Yes. Hello, everybody. My name is Arnaud Gastelblum. Like Isabelle, I didn't know that you don't answer your phone call, but I really dislike it too. So do not call me, please, but send me email. You can reach me by email. Otherwise, I'm trying to do some blog posts and I'm sharing stuff on LinkedIn. That's what I really like. So please connect your LinkedIn account if you want. I'm a Microsoft Data Platform Consultant, which is a really nice name just to mention that I'm working with Power BI, SQL Server, analysis services, integration services, everything related to the data and Microsoft. Just for your information, I'm a father of two little monsters, Pauline and Antoine. Isabelle really don't like when I mention it, but I like running. So if guys, you like to run, so please give me some motivation on Strava and I will bring you some motivation too. That's very important to me to mention the running. Today, the goal of this session is to talk about Power BI, sure, but in Kimball, because we will talk about Kimball, which is the great master of the modeling of the data. Okay, it's definitely not a training. Okay, we have 45 minutes, I think. We like to talk, and then it's just to bring you some advices and maybe to let you have some idea and bring you some curiosity to change your model and to have a better way to present your data. Okay, Isabelle?
Yes, sure. So why data modeling? Why are we so obsessed with that? Because Arnaud and I, we are totally obsessed with the Kimball theory and the star schema model. It is not because we are like, super rigid and perfectionist, but it is because actually, if you want to have, maybe you are a little maniac, to be honest, but without a proper data model, there is no performance. I will be very surprised if you have a good performance without a good data model, and it is not practical at all. So we have a Bible, and it is like 40 years ago, I think, maybe more, that Ralph Kimball and his team has elaborate the dimensional modeling. So let's go into that.
Yeah, 40 years ago. That's nearly my age. So let's go with this first topic for BI love star schema. Okay, and let me just introduce the case. What is a star schema? But first, this is something I usually met, and I think Isabelle too, and I'm sure you too, to our client. People like to load the data like it is, just to keep all the information like it is in the source system, which can be databases, SQL Server database, maybe files and stuff like that. And they are building a relation between those tables. And this is nice. It's already this is a data warehouse. So you are storing data in Power BI. You are building a data warehouse. So let's imagine now you have a user who wants to filter some attributes in a different table. Here we have loyalty card, zip code, and maybe another attribute in the product table. Okay, and they want, on top of that, they want the sum of sales amount, which is in the sales table in the middle of this model. And there is something happened during the in the engine during the filtering. This is the filter propagation. You know, when you have different table, you have a relation between, and you have a small arrow to define which table will filter which table. Okay, and there is some propagation of this filter to go directly to the one you will apply the measure, in this case, the sum of sales amount. There is 3 issues for that. I think first, the user has already a lot of complexity to understand the model. Or I mean, they don't know the model, but they have a lot of issue to already understand what you did, the DAX measure, the data behind. It's quite complex, okay? So if they have to understand the relation between table to be sure that the data they are asking is the one they really have, okay? And this is the first issue. And you, at least me, when we are building very, very interesting DAX measure, because we are the warrior of DAX and we build something really complex. Imagine now the behavior of your DAX measure can change because of that filtering propagation, and it can change all the behavior. It can be complex to understand why it doesn't work like you want. And filter propagation, it's also for the engine, it's a bit more, it's a bit less performant. They have to filter one table, will filter one or many other table, and then at the end, many table will be impacted. So in terms of performance, this is the not best case, which is the best way to introduce the star schema. This is the best case with Power BI. Why? Why a star schema? Star schema is because it just looks like a star. In this case, you have in the middle a fact table, which is a table where you have all the event. In this case, it's the fact sales, which is the event sales. So one row define one event of sales. And one row of this table is, and the word is very nice for that, one row in this table is dimensioned by different information. And those information are the black table you have outside the fact sales here. So one row in the fact sales is dimensioned by a date for a product, for a customer in one store, and maybe for one reseller, okay? And the user will be able to do filtering, grouping, showing information from the dimension, so the black table here, information for customer, for product. And normally you're doing your measure calculation on the fact sales, like the sum, average, and all the information you want to do with the time intelligence, stuff like that. Okay, you can also do distinct count if you really want on the dimension. You can do measure where you want. That's the best way of working. So let's go back to the first example I mentioned. Normally, we can change the data model. We can change all the table to have something like that. Okay, we have the dimension where the filter will be applied, grouping, and in the middle, we have the calculation on the fact table. That's the best way to do because it's simple to understand. You know, where you have a product table, you filter something on the product table, and your filter propagation will be on the fact table in the middle. That's easy to do for the user, for your DAX measure. In terms of performance, you can imagine you only filter one table, which is big normally, and that's the best way to work. And it's also very nice. You can, but you have to reuse the dimension. If your dimension, like product and calendar in this case, are very well defined, you can, and you have to reuse it. Let's imagine here, we have the sales, okay, but now we want to store the data for the stock. And we know that for a specific date, we have some product, and we know that we have 10 Apple for a specific date. That's very nice because we are reusing the dimension, and in the graphic, in the report, a user can do a table and compare for one product for one specific month or year, can know the sum of sales amount. They can also know the number of stock they have, and they can build some correlation, some relation between, you can build a DAX measure to have this information. That is the perfect way of working, reusability of your dimension and building many different measures. Another topic is the surrogate key. It's a technical topic, but it's just the way to introduce something very important when you're building your model, at least your dimension and your fact table, is to think about the granularity. Okay, granularity is very, very, very important. When you have a dimension, for example, you have to think always what is, and I like to mention this name, which is the skeleton of my dimension, which will define one row in this table. And for that, we need to define one or multiple attribute in that dimension. It's called business key. You have to define what was the business key for one dimension. And let's go for an example. We have the calendar table, which is the most simple one to understand. You can imagine, and if you ask you the question, I have a calendar dimension, one row. What mean one row in my dimension? And one row is one date. You can have multiple information, but there is no meaning behind to have two rows for the same dates. Okay, so the business key for the calendar will be a date. For customer dimension, you can imagine this is the customer code. Okay, let's imagine the customer code is 10 because that's something with on the loyalty card, on your account. When you buy something, you always carry the same customer code. That's easy. This is the business key of the dimension customer. But let's imagine now you have a big company and you have one store in Belgium, another one in France, and there is no information sharing between the customer. So this is maybe two different source systems. And you have the customer code 10 in Belgium, customer 10 in France, but this is definitely not the same person. Okay, so customer code can be the unique, can be the grain of your dimension, because there is two rows for customer 10. That's why you need to add a new business key, which is market area or store or maybe country in this example. And then those business key, because you can have multiple business key. The idea is not to have a lot, but if you have a meaning behind, that's normal to have many different key to define the grain of your table. And because Power BI, I mean modeling doesn't like that, you have to have a surrogate key on top of it. And surrogate key is a technical key, which will be the primary key, or will replace, like the name mentioned, will replace the business key. Okay, so because this key, this technical key will be attached to a fact table, you only need one, because Power BI is not able to do many, to use many key to do the relation. You only need one. That's the surrogate key, the primary key, who will be used. I'm seeing that Isabelle is not there. So there's somebody in the chat. Do you hear me? Thank you. So normally this is a topic for Isabelle, but I think she is not there. Thank you, Peter. She had some issue. She's living in Brussels, so I don't think she has the best internet. I'm kidding.
There's something happening over there with Isabelle?
I don't know. She's there. She's back. Isabelle?
Perhaps
Yes.
the screen is like stuck.
Yeah, that's terrible. I'm sorry, but my surface is dead, so I had to switch to another one. Just let me change my camera to the one of this laptop. Yes. Okay. Can you see me?
Yeah. I need to give you some. Do you see the screen?
I see the screen. I'm not sure though I will have the control because I'm on the web Teams for the moment, but otherwise I will just ask you to
yeah, well,
for me if it's that okay. So
I will be
yes.
your right hand.
That's the nightmare. Every speaker hope will not happen, but it happens. So okay. Now, can you click Arnaud? We will go through some very specific dimension. For instance, you may know this, what we call the snowflake. And snowflake is when the star schema is growing into like a snowflake, because, for instance, you have a dimension with your product, and then you want to add the category and the subcategory of product. And because in the operational database, this is done with different tables, you are just keeping that way of working, which is not good in Power BI. So in Power BI, we really prefer to consolidate all the needed attributes into the dimension. You will have less table, meaning less storage, less metadata, but also less relationship. So your model will be more efficient, and also it will be easier to understand. That's the cherry on the cake. So keep it simple, and do not worry because you will have duplicate value. It doesn't matter in Power BI to have duplicate because of the Vertipack engine. All of your column will be compressed. So duplicate, we do not care about that at all. Also, if you are using a snowflake, you will not be able to create a hierarchy from your table. If all of your relevant attributes are in the same table, you can create clean hierarchy as well. So that's for the snowflake. Can you click?
We did, but it doesn't work. Wait, up. Yes.
Okay. Another dimension is what we call the junk dimension. It's a little harsh, but it's what it is. So it's a made-up dimension that we use to put all together all the small dimension attributes. So it is like a Cartesian product of all the dimension attributes, the little ones that we want to associate to a fact, but we do not want to mess up with the model with a lot of dimension. So the benefits is the size reduction and the simplification of the model. That is interesting, of course, but you need to think about it like, okay, it is a Cartesian product, so I will use the columns are their dimension actually. So it's a little special. It's a special dimension, and it's called junk. That would say something to you. Then we have the degenerate dimension. We can discuss about it, not now, of course, because some people like it, some people don't. Although Microsoft recommends sometimes the usage of it. So the idea is the following: it's to keep the fact table without any attribute. So in a fact table like this is, we will say, okay, the order number, for instance, or the line number, I will put that into a made-up dimension, sales order. And of course, because it is extract from the fact table, you will have a one-to-one relationship. What it is interesting is that it will normally, it could be better for your performance as well, simplify the calculation that Power BI needs to do, and also it will add up a dimension, and dimension are access of analysis to your user. So that can be interesting. So this is one of the choices that you have. It's coming from the Kimball theory, and you can do that as here in Power BI also. Click. And now, a very interesting concept, it is what we call the role-playing dimension. So the role-playing dimension is the fact that I'm pretty sure everyone that is using Power BI is confronting this problem one day. You have a time dimension, the calendar, the dim date, whatever you call it, and you have your fact table. And in the fact table, you will have different dates. For instance, here, we will have the order date, but also the due date and the delivery date. So we have 3 dates here and only one dimension. So there is different technique to be able to use either the due date as an axe of analysis or the delivery date. To do so, in the first technique, you will just add relationship. But as you know, if you do that, you will have only one relationship that is active. And for the rest, you will need to explicitly use the function use relationship. You will not have any self-aggregation as well, because the relationships are inactive. So you need to create a measure for each of the relations that are not active as well. And at the end, you can end up with a lot of measure for each variation of date that you may have in your model. Also, you cannot do simultaneous filters on the date if you want to filter by due date and by order date and so on. Can you click? Although I will show you a solution for that, a very elegant one that we think about. It was a suggestion of Arnaud and I made it and it was really nice. So I will show you that into the demo. We will use the calculation groups. The second technique that you can use for the role-playing dimension, if you can click, Arnaud. Okay, it is the duplicate of the table that you need in your role-playing dimension. For instance, you will have 3 dim dates. So you will duplicate the table. Is it a good practice? For a dim date, it's not a big one, so that can make sense. And you can do it in different ways. You can do it in DAX with a calculate table. You can do it in direct query mode. And you can do it in import mode if you want. So all of the place where you can create a table actually into your model. Of course, you can be a little worried about the storage and about the performance, but the benefit is that after that, all is clear. Maybe not for the user, but all is clear because you have your regular aggregation, filtering, relation, all is active, all is usable. So now it is time for the demo. I am just hoping that I will be able to open my file here from my other PC. So just give me 1 second before I share my screen. Okay.
Are you using your Raspberry Pi?
This is not even funny.
I know. I'm trying.
I'm just keeping the good face here. And I am opening the files. Okay.
So in the meantime, if you have any question in the chat, I can answer during the presentation. Do not hesitate.
Yeah, a little suspense for that.
Question or idea.
That's terrible. It is definitively not the day I will play at the lotto, of course.
It's a sunny day here.
It is. It is. It's okay. The first one is done. And now my second laptop seems to have some troubles. I don't know why. Oh, yes, but of course I have a lot of... Okay, that should be okay. And I will share my screen now. And let's have a look at that. Okay. I hope you can see my screen.
Yes.
Yes, so at the moment you should see yourself.
Yes.
Okay. So this is The first solution, I will go to the diagram to show you that. Here, and of course, this is a little messy. And I will just show you here that I have indeed a pretty neat star schema with the sales as the fact, and then we have the product, we have the salesperson, we have the customer, and we have the calendar. And as you can see here for the calendar, I have a relationship between the sales date and the calendar, and I have other relationship with invoice date and delivery date. Okay, so this is technique one. Normally, I should use a lot of measure and I should use a relationship to do that. As you can see here, what I have done is that I am not able to use whatever context of date I want to use, so whatever relationship I want to use, but what I have used to do that is a calculation group. So let me show you that by opening Tabular Editor, of course. What else? This is our best friends, one of our best friends, isn't it, Arnaud?
Yes, not this one.
The idea is the following. If you are familiar with calculation group, you can think about them as a kind of mask that you will apply to your measure and that allow you not to repeat every time a function that you need to use. So in that situation, this is actually the fact that when we use a date, the relation may be not active. And so by creating here my calculation group with, for instance, the delivery date, in that case, I am just saying the model, okay, use a relationship between delivery date and the calendar. For the invoice date, it is quite the same. And for the sales days, it is the active. So I am just using selected measure. And by doing that, I am now able to benefit from the custom aggregation if I want. So if I go to my, my sum here, it is just a sum. And you see, it's really the regular aggregation. And I'm just changing the relationship context here really easily. If I am using technique 2, I don't know if I have the time to do it. Let me have a look.
Yeah, 15 minutes.
15?
Yeah.
Okay, so maybe because the other technique is quite simple, I will not demonstrate this one, and you can share your screen again.
Yes.
Okay,
Because
but do not hesitate to reach us if you want more explanation about that.
Perfect. Do you see my screen? I think it's okay.
Yes, it's okay.
Perfect. Nice. So yes, it was a demo. I have a lot to mention in 15 minutes, and this is a quite interesting topic, which is the slowly changing dimension. You can call them SCD in the meantime. It's the same. It's just a big name just to explain how to have historization of your data in your model. Let's imagine you need historization for a customer. Let's go for an example. You have a customer which is Pauline. It's also the name of my daughter. And and it's not true, but she was in 2015, in this example, in Germany. She moved in France in 2019. And since 2021, she's in UK. So over the time, the country information changed. And that's what we want to keep in our data. SCD, slowly changing dimension, can be can exist into different types. Okay, you have type 0, type 1, type 2, and many other types. I just keep the focus on 2 types because it's the most common. It's a type 1 and type 2. fun fact, I like to say that type 1 SCD is something you can add on your CV because that's something everybody does. When you refresh your data, you overwrite everything. So you don't have historization. You have the latest and fresher version of country for Pauline, and it's UK. You don't trace the information. You have the latest version. SCD2 is just adding new rows. Each time you have a new information with a different kind of data meaning behind. Here it was country. You have a new rows in your dataset. Okay, let's go for a most complex way to store the data. In this example, we have Pauline, the attribute country, who change over the time, and the first attribute, it's the P key, which is the surrogate key. If you remember well, we will be sure that this is the unicity of the table in terms of technical, and each key will be attached to the fact. Let's imagine Pauline bought some stuff some product in our store when she was in France. So we will attach each each rows of fact sales to the P key 1, 2, 3, 4, 6, which is the second in the line when she was in France. So we are able to attach everything to Pauline, and we know now where she were, and she was in France at that time. We have the start date, end date, to be able in the dimension customer to reproduce the timeline of this customer, and date it's commonly the day before the next row. This is nice to know, but I mentioned the business key. Business key, this simple example is maybe customer, which will be customer code, but the business keys of this table, it's now the customer and the start date and the end date, because it's the way to not to be sure that the granularity is unique. You can, best practice is to have version. You can have an attribute version like 1, 2, 3, 4, 5. It depends the number of rows you have. You can also have current attribute like it's a flag boolean, no, yes. So the latest is flagged to yes. I also like to use the version descending to know that it's not 1, 2, 3, but 3, 2, 1 in this case, because we always know the 1 is the latest and fresh version of Pauline. But another way to work, and I like this idea, is to have to just keep information and historization to some different attribute, but maybe here the country, we keep the historization of the country and we provide to the user this information, and we define it as East. You see here, you have the East information, country East, and then you have a different value, France, Germany, UK. But for each rows, we can keep a country and just set the latest and fresh version of country. Then we let to your user the way to think. Maybe they want the historization, maybe they doesn't want, because there's maybe we want to know for UK what is the possibility for this customer to buy many other stuff, and then for that we need to know what she bought in the previous year. That's maybe an idea. So that's perfect. There's historization with SCD. We like it. Everybody is happy. We can do it. But I don't want to fight with you. I know I already had the discussion with many of my colleagues during the coffee break. I was able to do it, so I did it a lot. But no, I don't like it very well. If you need it, do it. But it's complex. I mean, it's complex for the user. Okay, it's not because we can do it that we have to do it. It's like I mentioned, it's complex for them to understand the data and stuff like that. So SCD can be complex for them. And based on my history, I would say, in my job, I think users don't use it a lot. Okay, maybe for specific case, yes, they use it. Otherwise, they don't need it. At the end, they just want the fresh version, and that's it. For you, I mean, for if you want to pay a BI specialist, it's okay. They are able to do it, but for maintenance, 5 years later, it's maybe complex, and for nothing. Maybe it's not useful for the user, so you spend time and money for nothing. That's my idea. If you need it, do it. And to set up, okay, Power BI is not able to do it. When you refresh your data, you have the latest and fresh version. Okay, so Power BI, you can do it. You need to do it in the source system. So I mean, in the database, SQL Server, you need to some mechanism to store the data. Maybe you have it in your ERP, in your source system. Maybe you already have from and to date. Otherwise, historization can be done directly in Power BI, except if you do some snapshot of the data and you try to merge information on top of it. That's it for the slowly changing dimension. Latest topic, and for French speaker like us, it's not that easy, but I train a lot to pronounce, is the fact table. Fact table, just a fact table, okay? It's just a fact table who are there to join two or many dimension, but there is no measure inside. There is no attribute who will be used to do some calculation. Okay, just a fact, but imagine you have the sales, but you don't have the amount of sale. This table exists to do the join and to do the relation. Here in this example, we have promotion. So we have the dimension promotion. This dimension promotion, this promotion is applied to a product in one store and for a specific date. So if we need the percentage of the promotion, we have it in the dim promotion, but maybe you don't have any amount of promotion in the fact promotion. Just a simple example, but that's it. It's just for relation of the table. But it's a way to introduce something very interesting. This is the many to many, which is a fact table, but we call them bridge table. An example, a simple example. We have two dimensions here. We have book and author, and maybe I'm author of a book, so I have a relation to a book, but maybe because I like to write book, I have many other books. It's not the case, but I would like to. But anyway, if I want to write a book, I have many books, I have multiple books attached to my key of dim author. I really like Isabelle, and we want to write a book together. So it means that one book can have one, in this case, many different authors. So you see, we have many relation from author to book, and we have many relation from book to author. And this is something we need to build with a bridge. We will do the bridge between both tables, and this is a fact table where you have only the key. You can add many other information. Maybe it's interesting to have a date or something like that that you can add in this table. That was the latest topic we had. So we will provide a slide. There is some French link, but otherwise there is some English link to learn more about the modeling of your data. I think we have 5 minutes, but just in 30 seconds, we think, Isabelle and I, we think everything you can do in your model, it's important for, it will define all your project. It's important for users, it's important for everything. If you have a nice model and you've put all the effort into your model, extraction and stuff like that will be okay, but everything, it's the main idea you have to have for to have the perfect project. That's it. Isabelle, if you want to add some other idea, otherwise, if you have any question.
I don't see any question in the chat, but yes, I want to really underline the fact that either you are familiar with Kimball and you want to translate it in your actual Power BI project because you are from this side, or you are new to BI and modeling. In each case, you will benefit of this approach. Also, and that's a discussion I always have with other guys in the IT. I'm really convinced that star schema is something that business user can easily understand, because it's very simple when you tell them in the middle you have all the information you want to analyze, and the dimension, there are all the axis of analysis, the filters that you want to use. And once they understand that, sky is the limit, and they can start to use your data set. I remind also that a very best practice in Power BI is to have what we call the shared data set, and to segregate your reports, your design, your visualization from the data set itself.
Yeah, to reuse the data, yes. You can unplug your mic if you have any question or suggestion or idea, or maybe you did some nice model and you want to share with us some information. Should not be stressed. It's Saturday, so
the worst already happened today to me, actually. And yes, it seems that my surface is really dead, so it's time for me to buy a new one, which is good news after all.
I mentioned it this week, yeah.
Yeah, so that's all your fault, Arnaud.
That's my fault, yeah. I think I thought about it. So no question or ID in the chat? Are you still there?
That's okay, I guess. So